Yeah, hello all. Hello, dear faculties. A very warm welcome once again for Data Analytics with IBM Cognos Faculty Development Program. Welcome you all on day 5. So, dear faculties, we'll wait for a couple of more minutes for other participants to join the session. Then we will start with it. So, thank you very much, dear faculty. Yeah, hello, dear attendees. Once again, a very good evening to all of you. So I extend a warm welcome to all of you. We are gathered here today for an insightful session. So without further delay, now I kindly request our esteemed speaker, Mr. Mohan sir, to kickstart the session for IBM Cognos. So I request Mohan sir to please take over the session. So, Mohan sir.
Yeah, thank you and good evening, Shubham. Good
Yeah,
evening to all our participants. Welcome to day 5 on the faculty development program on data analytics with IBM Cognos. Am I audible to all of you clearly? Yeah.
Yes.
So we will go ahead with the discussions in continuation to our yesterday's session. Yesterday, we just started the core of data pre-processing. We could explore some rigor exploratory data analysis on the use case of bike buyer analytics through visual insights. We would now discover the art of building a business intelligence dashboard how dashboards become very intuitive and effective in understanding critical business insights of complex real-world scenarios, how dashboard can be designed and made interactive using different visual aids will be discussed in this day 5 evening session with you all. Before we move on to building a corporate BI dashboard, let's deal with the residual left over yesterday in our session, that is how to tackle with the inconsistent and noisy data as part of the data pre-processing. During the closure of the session, we witnessed how we could handle missing values, and for a continuous variable. We would also now demonstrate a quick recap for the benefit of all participants, how to treat missing values and also discover the presence of anomalies or outliers in the data set. Once we are done, we'll be moving on to our topic for today, that is designing and building a quick introductory business intelligence dashboard. Welcome everybody once again. Request all the participants to kindly open your Cognos Analytics, the web-based Cognos Analytics tool. Hope you all can see my Cognos platform clearly. I'm on my Cognos tool currently. Let's start with the completion of yesterday's exercise, quick one, and then we'll proceed to today's. Yesterday, we were working on bike buyer data set, where we could have a handful exploration with rich visual insights, creating data patterns through various visuals like stacked bar, stacked column, and other associations. How these are useful to establish the point of connectivity or inherent relationships among the data. We will once again use the same data set for this thing. But first, to conduct data pre-processing, as we all know, we have to create a new data module. So from the open menu, choose new option and then click data module. Select your required data set that you are planning to pre-process, that is data cleaning. Although data pre-processing has many integrated processes within it, we are confining the activity to perform, understand data cleaning. Other synonyms for this are data wrangling or data cleansing. Select your data source. This will redirect us to the data module page. Select your data set and choose grid. Now you can view the data that we were working yesterday here with. The data is having certain inconsistencies and noise. The inconsistencies or incompleteness is the presence of null values, nothing but the missing value. And we also had some unusual data present in it. Typically, we would detect that today with, once again, basic EDA. First, we should identify what are the fields that have the nulls. You could randomly notice there are null values where data are missing at random. This is the data missing at random. So we could see here for some categorical columns like marital status, we have the null value. Gender, which is categorical, we have the null value. Children had null values or missing values. Similarly, we also have other fields that have the missing value challenge. So we can walk through. So you can see this. The best way of catching out null values from raw data, because raw data is big data that is voluminous and varied, one of the most easiest and fundamental method of determining null values in Cognos is to go through visualizations. Exploratory data analysis is that's why a fundamental step for most analytics projects. In the visuals, the null values are represented, especially if you see for categorical variables, the null value is also treated as separate category. So for example, if the column gender or the variable gender has null values, typically the two class labels for gender include male and female. But the third category null is also detected by the visual scheme, like any bar graph or any column or whatever visualization we are using in place, that would be detected, and null will also be projected as category. Whenever we say a null category on a graph or visualization, the data analyst or Cognos user should understand the chosen variable is suffering from null values. Additionally, there are special type of visualizations that can also depict presence of anomalies, outliers, typically the box plot that we will see today. First, let us handle whether we have the problem of null values here. Yes, we have yesterday yearly income and children had null values. Once again, I am demonstrating here. So to clean the data column children, which is a continuous column, that is the data distributed on a continuous scale. So you can just right click on the children column, choose properties participants. You can also do hands-on alongside with me. Then in the properties section, one has to understand what is the usage nature of that column. Because the data under children column are distributed or spread out, typically analytics tools like Cognos and others identify the data item as a measure. Whenever we see a data item as measure, we should understand it's just not a column, but it has a continuous distribution of values. Other than measure, whenever we choose a categorical variable like marital status, like as gender, that would be identified as attribute. So whenever we see an attribute as usage, we should understand that it is a categorical variable. Other than measure and attribute, sometimes we see the identifier. Identifier is used as usage measure for values which are unique. For example, first column ID, if we try to clean the data, which of course is not a important significant variable, Cognos understands it as identifier. That means unique value variable. So let's start with our measure in place. In order to build the data cleansing process, we need to create and evaluate an expression. That's why we will now edit one expression here on the chosen field. The chosen field is children column here that we have in place. We have a bunch of functions available. You could see that. Cognos provides rich mathematical modeling for its data parameters, ranging from operators to aggregation summaries, using some constants and decision-making constructs, etc., and so on and so forth. So to evaluate expression, we all know that constructs are available, such as simple if-else construct or case construct or simple case, etc. For the purpose of the problem, we are choosing if then else. Where is it available? It is available under the view or edit expression and choose your function button. This will open the function builder on the Cognos. Then choose the right construct and try to build your construct. Now this is a general syntax of the if condition, as we know. If we evaluate a condition, if the condition evaluates to true, then one expression would be written, or if the condition evaluates to false, another expression would be executed. So our point of interest is a variable children here. So select it and try to deposit it in the condition here. Now how to instruct Cognos whether the chosen column has some missing values or not? There are operators, relational, logical, conditional, all type of operators are supported. Standard operators are available in Cognos. So we can then proceed to operator section. All participants can choose the hands-on. Again, try to operate alongside with me. First, we have chosen children variable, then right-click properties. We are now editing one expression from the function builder, and then we have chosen if-then construct. Then we try to attach a logical label to Cognos indicating if children is missing. We'll try to position it exactly if children is missing. This logical function would evaluate to true. Is missing will return true if and only if the children column has null values. Is missing will evaluate to false if children column doesn't have even a single null value. So you can consider it as a logical expression. Then if this is true, what should happen? Then we have to do some calculation. Because children is a continuous data item, we need to find out some meaningful replacement that would fill the place of a null value. There are different imputation techniques, as we discussed like yesterday's session: mean imputation, median imputation, and mode imputation, which are commonly used statistical data cleansing techniques. More robust analytics experts, other than the basics imputation, might also go to apply a computer algorithm or a machine learning algorithm like k nearest neighbors that can also generate some predicted values which can be substituted in place of missing value. For instance, if we give a set of available values called observed values, KNN algorithm could generate some predicted values. Such predicted values will replace the null values in order to have the inconsistency avoidable. But those are on the higher typical end. But for basic data analytics to start with, these minimum experiments are sufficient enough. So we will just rule out this expression and then we'll try to apply some kind of a statistics. We'll compute some statistics here. I'll go to the summaries. Our idea here is whenever the children count is missing for a respondent, we'll try to take the average of the available children count for each respondent or entire data set as a whole. Then we'll replace the average value in place of the missing value. So choose the correct function. There are a plethora of functions in Cognos participants for you to choose. Average of. Then you can view the function here. Which column? We are interested to select the children column. You can just rearrange this here. So we say, please perform average on children column, produce the mean value, substitute such mean value in case of null values under children column. So we developed this if then else construct, and then we are now ready to evaluate it. If children is missing, then perform statistical, then evaluate the expression. Yeah, we will replace. Otherwise, if in case if it is false, or in case if the data item doesn't have null values, the else part will remain as it is. Now let's validate here. Yes, now the expression is valid. Make sure participants you are able to design the if else construct as it is. The logical condition, if then an expression, if true, then perform a statistical imputation with mean, else means false, leave the children column untouched, that is undisturbed. Once we perform, make sure you click on OK. If you click on this close button, the backend data doesn't get imputed. I repeat, once you build the expression as it is evaluated logically, to execute that expression, you have to click on OK. If accidentally one clicks on close, the expression is ignored and raw data remains as it is. So to apply the effect of the imputation, click OK. Cognos is running the expression that we created in the backend. And now you can notice that the calculated mean value of the children, the average children has been calculated. Yesterday we could discover in the raw data the children distribution per respondent ranges from 0 to 5, where 5 is the maximum number of children, while 0 is the no or minimum children. So we could successfully replace the missing value with a mean value. You can just explore that all wherever this value is found. Yes, wherever this value is found, this indicates the replacement of null with a mean value, right? So this is how a simple numerical continuous data item can be replaced with. Similarly, we can also handle similar problems associated with categorical variable. Please check and confirm, participants. Hope you all could get how to deal with missing values in continuous variables. Could you all perform the data cleaning on your side also? Please check and confirm. Yes, thank you, Sharanji. Now let's take the opportunity to understand how to tackle or handle missing data in case of a categorical column or categorical attribute. In our given data set, attributes like marital status, gender, all might have certain null values in this. To get a hold of the null value presence, one of the beautiful benefit from Cognos and other tools is null value is also projected as one category in the visualization, which is a direct indication to the user that null values are present in the data set. In case if a null value is present, then how to handle? For instance, let's take marital status. I'll try to choose properties here. As you can see, marital status is being used an identifier by default, although it can have certain categories. Depending on the nature of the data type, nature of the data that contained in the data item, Cognos tries to distinguish each of the data items in its own essence. Now we're trying to build some expression on it, on the marital status here. We all know it is a qualitative item or categorical in nature. So again, follow the function builder, open the function builder, try to develop an construct using if then else on the chosen variable. So we have here the marital status here, column. which is being examined using an if condition. That becomes the input for our logical condition with if such a field marital status is experiencing some null values, so indicate the flag a condition that is missing. If marital status is missing, is what the expression we are building. If this evaluates to true, that means if marital status have null values, then what should be the result? There are different techniques, as I was explaining yesterday. But how to replace? There are two methods. One is a standard imputation with some statistical observation or exploration. Second, go with certain predefined category label. For instance, if I would like to request you all to switch here. Okay, just have it here. Fine. I'll first complete this exercise, then show the exploration. Imagine we would like to replace this with a predefined or user assumed categorical label. Why we are going with not a known imputation rather than a categorical label? I'll brief it. Let's assume instead of the repeated most occurring gender can be either most repeated marital status can be either single or married or diverse from the given data. One of the choices can be given as an imputation technique, but that otherwise would imbalance the data and would lead us to a different analysis. So we have two parallel imputations here. One is we will try to just give a meaningful user defined label here, that is other, else we will try to use the same undisturbed column name in case the column doesn't have any missing value. So the expression goes like this. If the selected column marital status is found to have missing value, then replace the missing value with the user created label other, else leave it undisturbed in case no null value. So this is the expression we have built. Try to validate the expression. Yes, the expression is correct. All participants are requested to do the hands-on. If then else. Now, once this expression is found to be syntactically evaluated correct, then we can execute this in the background. I could see here in place of missing values, wherever we had missing value in marital status, the user created category is being now reflected. You could all notice that. Please check on your side also, participants, whether you could impute, fill the missing value with user created assumption. Now, when we project this data visualization, the other category also reflects in each of the visuals or carried forward to even dashboard or report or story point also. So rather than having a null as an identifier, it's more meaningful to have certain label that adds a certain value to our analysis. That is one way. The other is like we need to first explore the data correctly and then decide an outcome accordingly or statistically. So for that, I'll just go to my exploration here. I'll just try to explore something value added today. Go to my content. All of you can now start exploring on the bike buyer data set. Please choose a new exploration page. We already explored and saved our EDA on bike buyer. I'll just start creating two quick visualizations here. First one, start visualizing. Let us choose a column chart as a basic one for the purpose. My idea here is I would like to study the distribution of marital status here. How marital status of the respondents are spread out in the data. We would like to explore by a visualization called column chart. So for that, the chosen field of choice is marital status here, which is column chart for your information, participants. Then we have the length. Also, I'm interested to count the number of categories of respondents under marital status. Now you could clearly see a graph being generated here. The married and single. For a better eye-catching visualization, you can deposit marital status in the color shelf also. Now, please notice this visualization, everybody, during exploration. There are two categories essentially, married and single. What about the third one? Clearly you can see the label no value. What does this no value correspond to, anybody? Actually, in our data, we had under marital status categories labels like single, married, and null value. That means some of the respondents' marital status was not recorded by the market research team. Cognos identified those null values and depicts that as no value or absent value distribution. Do you think this is very difficult to understand? It's a straightaway indication to the analyst that there are some missing marital status. Thus, we cannot take this data and give it to a computer algorithm, because computer algorithm might better understand these patterns and might ignore because no data was there. This would lead to wrong predictive modeling. That's why let's add some meaningful identifier in order for the future predictive modeling or algorithms to have better yield for us. Given this visual insight, which marital status category is found more in the data set, participants? Anybody? Given this visual insight, you're right, Georgie. Married are more observed in the data set. Thus, without any ado, we can pick up this category because the most repeated category as our substitute for null values under marital status. Such a technique is called mode imputation. Because for categorical items, we cannot apply mean and median. They are applied only for continuous distribution variables. Mode can be a better choice. So after exploring this reality or insight, we will now switch to our this thing, that is our data module that we were working in. You can switch between the web pages or windows. Thus, for marital status, another method of imputation I'm showing here. You can just drill down here and choose properties. Under properties, once again, we will create the expression here. We'll create the expression, and then we'll try to rebuild our expression here. We will delete all this here. Then we'll go to the function. And then we will choose the marital status, which is our current method of observation. We have married, other, and single. Currently, other is already there. So first we need to recap the original one. So what I do is I'll just close this one without saving it here. I'll just try to close the current data module, which already was imputed, but we didn't save it. So I'll rebuild it from scratch again for a better understanding. Open menu, go to data module and choose your data set by buyer. One method was to fill the missing value with a predefined label category. Second one, we would like to go with a statistical mode imputation. So this is a new data module, again with the same data set having null values under marital status. Now marital status, then choose properties here. Under properties, we will go with our expression evaluation. Now we will go with the same process using function builder, explorer. Then we will go with the constructs in place. We will use an if then else construct on the variable being examined. We'll use a variable as logical condition. We will pick up the is missing operator for your information. Drag and drop the is missing operator. Position it correctly in the evaluation expression. Then what should be the condition here? Anybody? What should we write here, participants? Now we could found something from our visualization EDA. Correct. The suitable item to be replaced is married in single quote. Correct. Why? Because more married people frequency was found in the data set under marital status. Thus, we have chosen that category label as the reputation. You can just replace with the given thing for a differentiation. Correct. Because case sensitive, analytical tools are case sensitive, they still consider the lowercase as separate category and might deviate us from analysis. That's why you have to be very cautious. In case if the marital status doesn't have any missing value observed by the tool, then we will leave it undisturbed. So this is the next method of doing a statistical mode imputation by exploring the data. As there is no direct function available, we discover the artifact from the EDA. Evaluate our expression here. Now the expression is valid. The rest is accept the expression and perform the data cleansing or filling the missing value. Just click OK. Cognos applies the expression in the background and cleanses the marital status column. Now, if you notice, in place of missing value, we have the married deposited, right? But do you think this method of imputation might add some other kind of imbalance in the data as we were discussing yesterday? Yes, obviously, most of the null values are dominated by the most frequent category. Definitely, the weight or the patterns would shift to the predominant category. If such a cleansed data set is given to the computer algorithm for predictions in future, definitely algorithm will focus on high dimension data. What is high dimension? Marital status has more married. So the probability of a missing value under marital in future will be predicted as married only, because the density of single patterns is quite low. That would lead to overfitting of the learning. That's why you must try with two methods. One is go with some statistical imputation if we don't have any choice, or better to give some value added insight. You can also define a redefined custom label to identify null as an other meaningful category. This is how we deal with missing values. Apart from this, we also have certain other problems called the outliers. Let me present that here first. Let me introduce you all to the outliers that we were discussing yesterday, which is due of it. I hope you all can see my presentation, participants, clearly. Added to the problems of data pre-processing, having knowledge of inconsistent noisy data is required. Typically, what is meant by outlier is usually some data points that are found in the raw data behave abnormally. How they are found is they lie far away from the regular data, or typically they deviate from the range or distribution of the data. Such outliers are usually mostly found in this continuous distribution variables. Ignoring such variables, ignoring such data items which have outliers might seriously cause a rapid deviation from the analysis of the project. Thus, measuring the outlier presence, identifying them and treating them is also part and parcel of data cleaning process. How do the outliers come out? I'm just presenting some chances of outliers, which are data errors. For instance, in the screenshot, you could see the data collected about some employees. First column is name, second column is age, job. Where do you find the abnormality, anomaly? One of the employees' age was accidentally entered as 255 years, which is quite a very far away. Why I call this as abnormality is if I plot a visualization on the age column, participants, while all the other ages of the other employees lie in certain range, only the particular employee named Jenny's age would be presented in the visualization 255 as a far away. Such deviation or such biasedness is very critical whenever we are feeding the data to a computer algorithm. Maybe in an exploratory data analysis, if we don't identify and try to devise some measures for handling outlier, directly feed the raw data, the computer algorithms would otherwise understand that data point also as a valid and might generate predictions on its capacity. To avoid such errors, we need to first start with identifying and handling outlier. Then, how outliers usually are characterized in a data set. From the study of statistical distributions, one of the fundamental distribution in place is the normal probability distribution, which is widely used as benchmark or standard for evaluating reliability of the data. Typically, a normal distribution is that distribution which exhibits a perfect bell-shaped curve, as you're seeing on the screen in the slide. The characteristics of a normally distributed data are the mean of the data lies at 0, and typically the data points are distributed between -3 and 3 standard deviations. The sigma notation on screen indicates the standard deviation statistic metric. So if any data, if you would like to, first of all, evaluate the reliability of the data, believe that the data can be taken forward for EDA or pre-processing or analytical modeling, first, every researcher should have the know-how of whether the chosen data or sample that you are using for your research is consistent, reliable, believable for analysis. That's why reliability studies are more important in analytical research. Any data that lie beyond the boundaries of -3 and 3 standard deviation units are obviously need to be identified as outliers. That is, anomalies or abnormal values in the data set. Then, for example, another one, sampling error. Sometimes the type of data that we choose as sample, research sample experiment can also be cause of one of the error. So what is sampling error? Let us see. In one of the experiment, a research analyst is trying to examine the speed of some automobile vehicles. The select vehicles are displayed here under the automobile column, while two variables are being examined as a research hypothesis, that is horsepower and top speed of the vehicle. If you see, for some of the vehicles, the horsepower and top speed are quite higher. The chosen vehicles, they can depict these are quite higher, right? But sometimes if you see, for other vehicles, the horsepower is quite higher, but the top speed is very low, which is highlighted in the yellow color highlight. So here, when we feed such a data to the computer algorithm, a typical challenge here is like the algorithm might learn certain unidentified or abnormal patterns and might deviate tomorrow when we are going to predict the top speed of a given horsepower of a vehicle. Yeah, can you see my current slide? It's being shown. Let me just, yes. I hope now you are seeing my slide, right? Yes, I hope you are now seeing my slide, right? So the study is all about, like, we are trying to study the impact of outliers on the data. Some of the vehicles have high horsepower and high top speed. Some of them have high horsepower top speed, while other vehicles have the horsepower is very high, but the speed is very low. Such a type of values which can have sudden deviation from the data need to be carefully explored and examined. In the language of analytical research, the observer could specially focus on these values as outliers. Then, how to start detecting outliers? In any analytics tool, one of the best way of detecting outliers is by projecting those data items as visuals. There are many visualizations that we could practice in this FDP, bar, pie, stacked bar, column, and so on. But there is one phenomenal data visualization offered by any analytics tool. The name is box plot, or the other name is box whisker plot. The basic idea of choosing or learning a box plot today is the box plot tries to encompass the distribution of a continuous data item between certain entities. Typically, the box plot groups the entire continuous data into 5 different elements, namely the whiskers and the box. So, for example, the minimum value of a data can be called the lower whisker or minima. The maximum value of a data item is called the upper whisker or maximum. While all the values lie between minima and maxima, the presence of the box or the box will tell us how data are distributed within, how densely are the data are distributed in the data set. Statistically, there is a lot of rich information that we can extract from the box plot. We can call the minimum as the lower bound, upper bound as maxima. Between the minimum maximum, there are certain other characteristics, namely the quartiles. In statistics, data quartiling is a very important approach. Usually, we can divide our data into 4 quarters, while the boundaries of the quarters are technically called quartiles. There are 3 quartiles, namely Q1, that is first quartile representing 25% of the data. Then we have Q2. Q2 is also known as median participants, which represents 50% of the data that as a sample that you have taken here. Then Q3 will be the third quartile, which represents 75% of your data. Why we are studying quartiles here is, in real world, for numeric data especially, most of the data lie between minima and maxima. As a statistician, as an analytical researcher, globally, many researchers are aligning their focus, emphasizing the focus typically on minima and maxima, because when we talk about data aggregation analysis, is it sufficient if we find the maxima and minima, or should we also go in depth and examine how data are distributed between minima and maxima? We should start with finding maxima and minima. We should also continue with understanding how data are lying around between minima and maxima, so that we have some idea about how data are spread out. Typically, to better understand the measures of dispersion behind using standard deviation, besides using variance like statistics, the method of using box plot visual analysis can be more helpful. Another advantage of box plot is, using the statistics, we could compute a metric called interquartile range, that is IQR. Mathematically, IQR is defined as the difference between the third quarter, that is 75% of the data distribution, minus the first quartile, that is Q3 minus Q1. Why we are doing this is, the IQR becomes the standard for assessing the presence of outlier. Once we calculate IQR, then we could apply some notation to identify the presence of outlier to determine whether given data are normally distributed or not. Usually, any continuous data item, if you take like age, income, salary, or any other numerical distribution data item, the chances of outliers would lie in the range of minus 1.5 times IQR. This is the standard range of the outlier, to plus 1.5 times the IQR. This is the standard range of IQR. This is the standard notation, Mamtaji. Why? Because if you saw the normal distribution graph, which I showed in previous slide, the standard deviation limits usually for a normal distribution range between -1 to +1, -2 to +2, -3 to +3. So -2 to +2, -3 to +3. These are the typical bounds for evaluating the presence of outlier. So on either tails, if you see, because normal distribution is a two-tailed graph for your information, the left tail and the right tail. So if you sum up, right hand tail 1.5 units, left hand side 1.5, which would make a total of 3. So if you break down the normal distribution curve into two equal tails, left and right, 3 divided by 2 is how much, Mamataji and others? 3 divided by 2 is your 1.5 units. That's why the presence of outlier was defined in the standard range to be minus 1.5 units, negative 1.5 units on left tail, positive 1.5 units on the right tail. That is how the formula was mathematically coined. Hope everybody is clear on how this range was coined here. Then we will have the, using this knowledge, we would now construct the box plot and try to see whether our data items have any outliers. But how does a visualization actually get hold of the outlier? Another important specific is, a box plot displays the outliers. Here you can see the hollow bubbles, circles. Sometimes the outliers lie below the minima. Sometimes the outliers lie above the maxima. They are above the maxima. Thus, anything which is above the maxima might be treated as outlier, and some treatments are available how to treat them. And anything which is below minima can be this thing. Possible treatments are delete those outliers from the analysis. Very fundamental treatment is like yesterday, how we started deleting the missing values. Same thing we can do. But one problem with the deletion already we discussed yesterday. While deleting the outliers, we lose some data points, sample size decreases for analysis. That's why we should also discover what are the other alternative methods of handling the outlier first. So for that, some preferred methods I will recommend. You can have a quick note of it. These are all the characteristics of the box plot which I elaborated already. Don't need to remove the outliers always, because you need to first detect and try to do some kind of imputation techniques. See, for in this the given example, you could see the marks obtained by a student in a classroom. While the distribution goes between 2 to 10, there is suddenly some outlier 100. So you can directly remove that outlier and then take the remaining sample. Because if you include 100 in this, will the mean value will increase or not? Check out. If I consider the entire research sample of the marks of student, because of the presence of a higher mark or unusual mark scored by a student, the mean would definitely higher. That's why to reduce the noise in the data, I simply remove the outlier here and take the remaining sample and then take mean, which the mean will lower. The mean value would lower down. Other technique is apply the natural logarithms. There are log functions that we could apply to transform our data. So each raw data item could be translated into some logarithmic form using the natural log functions. That would reduce the dimension or the nature of the data distribution or variance in the data. So if outliers are not properly handled, do you think participants, can they introduce standard deviation and variance in the data pattern? What do you say? Because of a high value or too low value, that is anomaly, the standard deviation and variance characteristics in the data tremendously increases. Such data which has high standard deviation, high variance, can we call as inconsistent data or not? What do you say? Data that exhibits high variance in the real world are inconsistent. Computer algorithms, if directly are fed with inconsistent data with high variance, the predictive power of that models will be very poor. That's why in analytics, a essential step after EDA, exploratory data analysis, is data pre-processing. Then only after careful investigation, the data are fed to the machine learning or AI algorithms for further modeling. This is one method. Next one is the trimmed means method. These are all quite basic ones, the trimmed means, but more advanced methods are also there using standardization techniques. In trimmed method, as discussed, the observations are trimmed at both ends. So if you see the given pattern, marks of student again or scores, we have either too high value or too low. The mean of the regular pattern was found to be 26 units here. So what we do here is we will try to reduce this deviation by trimming off the unusual data patterns at both ends, at the lower end and upper end. Then we will take the possible available data and then calculate the trimmed mean. Look at the difference in reduction of the mean. Earlier with raw data it was 26 units. Now after trimming both ends, we could reduce it to 17. The idea of trimming the mean is to reduce the variance in the data so that data points lie closer to the mean. When data points are closer to the mean, we can easily find out or depict certain pattern in it, inherent pattern in it. This is called the trimmed means method for handling our outlier. Then we also have certain other methods in place, that is the Winsorized mean. For your information, the Winsorized mean, unlike the trimmed mean, is like temporarily cutting down or censoring the adjacent values. Consider the same scenario where we have certain data scores of a student. The given data points, minima is 1 mark, maxima is 100. The regular mean was 26 units. So to sensorize this, what we do is we'll try to replace the minimas and maximas by the adjacent values. So the adjacent value to the minima is already 1 here, we know. The very next adjacent value is 6. That's why we replace the minima with the adjacent. The maximum value is 100 here, the score. Then adjacent value to 100 is 36 here. So we replace the boundary with 36. That's why this is also one method where we could reduce the mean by censoring the adjacent values with the maximum and minima, and then we could reduce the mean or variance in the data. These are all quite basic techniques using the fundamental observations and certain statistics. Then we have the least median of squares method. That is, we can replace the outliers with a median value. Too far away values can be first calculated with a median and they are replaced. But how to detect them? While these are all replacement techniques, the detection technique obviously is through data visualization, which is our box plot visual. So let us all go to our Cognos analytics now. Once again, request all the participants to switch over to Cognos. If you're already there, that's okay. Then let me do some data exploration here. I'm already in this exploration project here. I'll just choose this one. I hope you all can see my Cognos screen, participants. Please confirm before I go hands-on. Yes, thank you. So I just begin with my job type here. Yesterday, we found that yearly income is quite a tricky variable. Do you all remember, participants? Yearly income had certain challenges. Could anybody recall what was the challenge we had in yearly income? Each respondent was given some income, but certain respondents' yearly income was labeled 0. Of course, there was an occupation associated with the income. The data itself reveals the fact. Like that, are there any other challenges in the yearly income variable? Let's find out the facts using the box plot visuals. So for the yearly income, which is a continuous variable, let's go and select the trend. Box plot fits in the trend analysis visualization category of Cognos. Choose the box plot. How to build a box plot? There are two things. Box plot is a two-dimensional visualization with X and Y axis. I'm interested to see how the yearly income are distributed. You can use box plot for univariate analysis, that is one variable at a time, or you can also use box plot for bivariate visual analysis also. First, we will see the univariate, that is, I just want to focus the distribution of incomes of the respondents, how the yearly incomes are spread over. Select the yearly income and drop it in the y-axis, participants, because the income scale goes on the y-axis. And then the key, which data item are we actually trying to focus on? Yearly income. So select the yearly income as the key item for box plot projection. Yes, this is how you have to build your box plot. I repeat, start a new exploration, or already if you have the exploration page, choose the box plot as current point of visualization. Examine, variable being examined is yearly income, drop it on the y-axis to get a distribution scale. And the key to be predicted, key to be explored is yearly income. Now we could see here, the box plot was produced. Please confirm, participants, could you get a similar box plot on your machine? Those are practicing. Type of visualization is box plot. Y-axis projection is box plot. Yearly income, key is also yearly income, correct. Then what does this box plot convey? The lower bound minima is corresponding to which income? Anybody? Just check out the box plot visual. The lower whisker or the lower bound is corresponding to 0. That means the minimum income of any individual in the given data set was found to be 0K. What is the maximum income actually? Here is where the trick lies. In our given data, if you observe, maximum income is some other value. For instance, let me show you the actual data set and what is the maximum income. Or in the Cognos itself, we can do that. I'll just go to my assistant here and type a query here, simply maximum income, maximum yearly income. So I open my Cognos assistant and request it to display, show me the maximum income. Maximum yearly income. What is the maximum yearly income here? You could see that 170K, right? 170K. But in the graph, what do you find the maximum income as? 60K, under 60K. Check out the box plot visualization, participants. There is quite a difference in the way that box plot understands the data. Why could the Cognos analytics assistant show the maxima? Why could box plot show a different maxima is a question of our concern here. Of course, the actual maxima is this, you can see here. This is the actual maxima of the given income proceeding near 170K. But Cognos restricted the maxima to the actual here. That is, the distribution must lie. Cognos analytics visualization box plot is suggesting this is the actual maxima to make sure the data distribution is accurate. There are two respondents whose income are quite higher, far away spread from the rest of the incomes of the respondents. While all other respondent incomes are in the range of 0 to 60K, there are two respondents whose income are quite found to be higher. Now, a question here for all participants is, do you think these two people with very high yearly income, can we consider them as our prospective bike buyers? What do you say? While the rest of people's income are in certain range, these two respondents' income are falling in abnormal, anomalous range. Can their behavior be different from others? This is what the suspect should come into mind. But normally, if you don't dig out this box plot whisker analysis, we could straight away go with maxima, opining that a maximum income person, do you think has high probability of buying a bike? Participants, according to you, what is your opinion on this project? Because market product sellers, vendors, they go with some psychology. That's why what the psychology says, find out the maximum player, believing that the maximum player has high capability to buy a bike. Is that assumption can be right or wrong? Please suggest your answers. Typically, any product vendor has certain opinions about consumer characteristics in the market. Those who have high earning will definitely spend high. Is it a fact that high annual income people are definitely spending high in the real world? Or low income people will not spend at all? Or vice versa, contrary? We cannot say. They are biasedness. There is no mandate, not necessary. Correct answer. That's why the other side of the thinking is also required. Why? Because if you think out of the box, a high annual income person might buy a car rather than a bike. This is another psychology of the marketer. That's why we should not blindly go with the maxima and minima. Besides checking maxima and minima, what is the actual truth lying between maxima and minima is now caught by the box plot. That's why this is a phenomenal visualization scheme offered by any analytics tool, including our Cognos data analytics tools. So any continuous data, if you want to study, you can study using the box plots. Imagine if I include my yearly income variable and feed it to my computer algorithm for future prediction. Would the algorithm suffer due to these outliers or not? What do you say? The algorithm, computer machine learning algorithm, if it finds the outlier presence, it will focus more on the outlier and tries to understand the data pattern. Yes, there is a maximum income. Probability of that fellow buying the bike is high. It will generate that prediction, which obviously goes very wrong. That is called problem of overfitting in machine learning. Similarly, sometimes we have outliers not only above the maxima, participants, we can have outliers below the minima also. That is too low values. And the box boundaries, that is, are called the upper whisker and lower whisker, that is maxima and minima. Look at the distribution, the blue color box. What does the box say here all about? If you see the box spread out, the size of the box distribution says what is the normal range of income distribution. How are the salaries distributed around? The most of the respondents' salaries are in a certain scale. And also look at the position of the box. Is it moving upwards toward the upper whisker or probably coming downward to the lower whisker as per the visualization? Anybody? What is the location of the box here? Is it moving upward or downward according to you? Check out the pattern. The box, the entire box, I mean to say, this box, is it moving downward close to the lower whisker or is it close to the upper whisker? I'm asking. It is moving downward. You're right, Mamataji. It is moving downward. What should we understand from this visual pattern? Downward means which income it is. Is it a low income or high income? The downward movement is low. That means a majority of the respondents' incomes are lying in the low income range. So our customers that we have chosen a sample for analysis are low income customers. How can this insight be a value addition to the production engineering team? Anybody? We are assessing near 7,000 respondents and found that they are all falling in the low income range. Can that knowledge insight be helpful to the bike production engineering team? I'm asking, how would it be? Definitely, this is the science behind the data, because the production engineering team will do optimize engineering and they will produce bikes which are suitable for purchase for lower income category groups, and typically we call this as high mileage low cost bikes, because middle income or low income groups expect what kind of bikes to be released in the market. Anybody? They would try to invest certain knowledge synthesis of automobile engineering and they'll try to produce a bike that offers high mileage at a low selling price. If that is the feature they incorporate, definitely the demand sales would go drastically higher. Imagine if the box distribution is moving upward, that means potential group of respondents have a higher income. So when they are higher income, that can also be a value added insight for the production team, because they would bring out the best end features like high horsepower, top speed, and such a type of features they could include and increase the cost of the product in the market. That's why a yearly income variable not only assesses the buying potential nature of the respondent, but also adds value to the engineering process also. This is how automobile engineering is now using artificial intelligence and rigor data analytics for better product innovation, I say. Do you all agree with me, participants? Better product innovation takes place with careful analysis, analytics of the business process data also. Correct. So that is how we could discover the presence. Then how to tackle these outliers? One way is we can delete these two, because out of the voluminous data, if we remove these two customers, it's not a great loss to the bike buying firm. But why should we delete these two? Because if we delete, we lose two customers from our sample. And how to handle? Best way is replace these two outliers. You can simply replace these two outliers with some specific data characteristics. Usually, many analytics tools follow the approach of data standardization or data normalization. That is, they replace all the outlier data and other data to lie in a standard range. Cognos also follows certain approach, but the best method is replace the outliers which are above the maxima. Currently, we have two outliers above the maxima. Replace these two values with the visualization suggested maxima. I mean, the two values which are abnormal, those values are replaced by which value, participants? What is the current maxima that you are seeing? Imagine this is the current maxima that our box plot suggested. That maxima will be replaced here. If we do that, do you think now the outliers are handled properly or not? No more outliers. When we see the actual suggested maxima by the visualization and replace it, now all the values are coming into a standard distribution or not? Similarly, if any outliers are below the minima, how to handle the outliers below the minima? Anybody? What is the suggestion? Take a chance. Any outliers which are found below the minima, how do you treat them? Cognos recommends you to standardize them and normalize them by replacing those outliers with the current minima. If current minima is 0, you can still replace the outlier with 0, because sometimes we might have negative values also as outliers. Negative values can also be outliers below 0. Such values can cause more biasedness in the data. So how to replace? Again, we can go with standard imputation, like how we were handling a numerical data item. Take the mean of it. Instead of mean, first you have to calculate the maximum and replace the maximum of the yearly income. Right, the maximum function would be applied, but directly when you apply a maximum function, the tool might consider the outlier as maximum rather than the tool suggested. That's why rather than going with a simple max imputation minimum, a better practice is to use certain techniques called standardization, Z-score standardization. One of the preferred method for handling outliers is Z-score. What is Z-score is, we first have to calculate the mean of the distribution. If X is a continuous data item, we have to take the mean of X and also standard deviation of X. Each X value is taken and substituted in the equation from the mean. The difference is taken and the ratio is divided by the standard deviation. Such calculated scores are the Z scores. First, we have to calculate Z scores of the incomes of each respondent. I mean, in the raw data given, first we have to compute Z scores using this formula, which is a mathematic behind, and then we have to substitute those values. Because of the limited capabilities in Cognos, this type of data treatment might not be possible through a visual. That's why other open source tools like Python, which have the inbuilt packages to handle this type of data pre-processing, are suited better rather than a simple data EDA tool like Cognos. I hope you're understanding why we have to switch between analytical tools for different project requirements in order to tackle with the real world data challenges. So this is about your data pre-processing opportunity in case of Cognos. Hope everybody is clear with all these participants. I would expect the participants to also add value by doing your parallel experiments that we are giving every day. You can also apply categorical imputation, mean imputation or median on the other numerical variable, because commute distance are also available. For one more clarification before I close, we would like to see whether any other variables in the given data set, do they have any outliers. So next variable we are going to examine here is the age variable, because age is also a numeric variable, right? We have the age variable. So let's choose the another continuous variable age. So let's see, age is being deposited on y-axis here, and the key item that we are going to assess is the age. One more box plot visualization you can practice, participants, with alongside with me. After checking the yearly income, now I am checking whether age of the respondent is having any anomalies or not. Now, what does this box plot tell? I have designed a box plot visualization on age column, age parameter. Do you find any outliers in the age column? Anybody? Observe the visualization carefully. Above the maxima or below the minima, do you find any bubbles? No, there are no outliers. Great. That means what should we understand? Age values are fairly normally distributed. The interpretation is age value distribution is fairly normal, no outliers. And clearly the box plot has elements: the lower whisker, minimum age; upper whisker, maximum age. The distribution, most of the respondents' age, the box distribution says somewhere above 40 and near below 80, 75. And if you look at the line, the horizontal line which is drawn horizontally, the black color line which you are seeing inside the box, this is called the median. That is 50% of the data. 50% of the respondents' age is closer to which age, participants? Again, I repeat, the middle color line where I'm hovering, moving the mouse pointer, is called the median or second quartile, Q2. It says that 50% of the respondents' age group in the sample is closer to 60 years. That is one insight that you could produce. The distributions go like this. This edge is called Q1 or first quartile. The horizontal line exactly in the middle of the box, this is Q2, and the top edge of the box is Q3, correct. And then we have the lower whisker, minimum. This is the minimum edge, minimum whisker, and this topmost edge is called maximum. Yes, closer to 68, right? The count is 68. So here we could see how the ages are spread over. This is the most distribution spread ages, right? Yeah, the count is coming to 68. The frequency count distribution is coming there. Thus, using the box plot, one can understand the distribution of a continuous variable. Do you agree, participants, with me? If any continuous variable is there in your dataset research, which visualization should you use to understand the distribution? box plot. Additionally, can we use the box plot for outlier detection also? What do you say, participants? Apart from understanding the distribution of data, outlier detection also possible greatly with box plot. Correct. That's why this is a value-added visualization in most analytical platforms. Now we will move on to our today's discussion, that is understanding the phenomenal dashboards for business intelligence. Permit me to present the dashboards with you. Now I am in my PPT. Let me share my presentation. Can you all see the technical presentation clearly, everybody? Cognos dashboards, day 5 starts here. After conducting basic exploratory data analysis and understanding the need and importance of data pre-processing in detail, after a great journey with basic analytics, as a data analyst, would you want to bring a summary of your business process insights in a consolidated, readable, presentable, and interpretable format, which is easier to understand for various levels of organization, ranging from strategic leaders to tactical leaders to operational executives, irrespective of the size of the organization? All workforce should be able to understand business processes correctly. Then if such is our need, then Cognos Analytics have a very tremendous facility for all of us to discover, explore, and re-engineer analytics through the phenomenal BI, business intelligence dashboards, I say. So let's start our journey today in this session with dashboards. As a passionate data analyst or a very solid researcher, if you want to explore data of the real world with IBM Cognos Analytics, it's not sufficient if we explore the data and leave it. Bring all the visual artifacts in a consolidated, homogeneous place and present the artifacts as true business intelligence for the organization. That's why such a structure that can be built is called dashboard. The idea of building a dashboard basically is to present or communicate the rich insights of the data in visual form collection, so that the top level, middle level management, and operational employees can all understand the inside out of the organization correctly. What is a dashboard? There are many definitions here. So a dashboard is typically like a visual display. But how to create, what to include in dashboard are all the prerequisites of this session that you all have to take away. Can we create any visualization and pin it to dashboard? Or should we first discover the important business KPIs, key performance indicators, and then prepare visuals accordingly and include such important metrics of the business process is where we have to understand. Dashboard is not just a collection of charts, participants, for information. Dashboard is a collection of rich visual insights that make the organization understand the progression of the business in order to meet their objectives. That's why information presented in dashboard should be aligned to the objectives of the business process of the organization, which is a very important understanding for creating the purpose. Tools that can be used to create dashboards in the market are IBM Cognos Analytics, which we are using, Tableau, Microsoft's Power BI, and so on, so forth. Python and R can also create dashboards with a bit of extra coding knowledge. This is a simple, quick view of sales and marketing dashboard. The different visuals that we could create in EDA can all be collectively brought into a single place and presented. The advantage of connecting the visuals in a dashboard is they are interconnected, making the dashboard highly interactive. So if you operate on one particular visual, its dependent effects are reflected on the dashboard collectively. That's why more insight extraction, collective insight extraction is possible when we pick up all the created visuals in EDA into the dashboard and deposit them, and then collectively visualize and analyze them. That's why the main purpose of dashboard, according to Gartner research, is to enable the management of the organizations to understand or comprehend how the business processes are moving according to the goals of the organization. or are they meeting the established set KPIs, that is key performance indicators, and how they have to understand the current progression from the data-driven insights provided by the dashboard and accordingly tune or reinvent the wheel of the business processes. This is a major purpose. Yeah, that I would answer, Zoebji. Building a dashboard is not a straightaway job. If one wants to go to build a dashboard, there are a lot of prerequisite steps to be performed. Unless the data are thoroughly explored and cleaned out completely, putting the data on a dashboard might be a certain risk or not. What do you say? See, a dashboard can be built with raw data, but what is the purpose of projecting raw data as visualization? What are we trying to convey to our organization management? Some patterns. That is called basic dashboard. But a business intelligence dashboard, do you think, does not project raw data, rather a thoroughly explored pattern and cleaned data only? Because a business intelligence dashboard is aimed at giving knowledge insight to the decision maker. That's why one must understand a true difference between a basic dashboard and a BI dashboard. Already basic visualizations we could build rigor on the EDA only. Thus, identifying key insights of the dashboard, key insights visualizations, and presenting the most important data patterns are very much imperative in building the BI dashboard. You're right, Amitji. Because this is a very important question at this point, because many beginners might opine, is it sufficient if I do some visualizations and then pin them to dashboard? Is my job over? No, that is a very basic dashboard only. So how to start building your dashboard? You have to select your data source, like any CSV or Excel file or any database table that you're working in. Then take a guided experience. That is, what is my guided experience is, fortunately, Cognos offers a step-by-step approach. First thing is, you need to start your dashboard project, select a required design, template or layout or theme, then accordingly connect the data source in the backend, select your required fields one by one and drag and build your visualization. That is the from the scratch building. We call this attempt as creating dashboard from the scratch. Other way is, as I demonstrated yesterday, we could build some visualizations in our EDA. That is, during exploratory data analysis, we could build some critical visual insights. Yesterday, recall my session participants, I advised you all to connect those visuals to the My Pins section, that is pin. So if during EDA, all the visuals that you have created, if you have pinned them, you can directly take over that visualizations from My Pins and drop them on the dashboard, which will save your value added time. That's why building the dashboard from the scratch is one way. Creating dashboard from the available pins created on the EDA is another quite impressive way. So both are possible. Then how to build a dashboard here? First, make sure you have raw data source. That raw data should directly be projected to dashboard, or should it be first turned into a data module? Participants, think and answer my question. Directly raw data should be connected. Zoebji says data module, right? Correct. Because in data module, do we have the facilities to pre-process our data or not? Exactly. In data module, we found that we can clean the data, handle outliers, catch the missing values and treat them. Do not connect the raw data directly to the dashboard. That is quite challenging. But I will show in this session with the dashboard on raw data. I'll give the opportunity for all the participants to connect the data module from your side as practice exercise. And on top of data module, you please build your BI dashboard as a practice that we will evaluate or assess in the last day for your project. Now, data model becomes the fundamental building block of Cognos, why we are using it. Great. Now we have this. We will start with some simple dashboard creation as a hands-on. After creating it, we will also learn what are the best practices to create a effective dashboard, or I will share some tips and tricks how to refine the dashboard for greater business intelligence. So let me switch to my Cognos Analytics platform here. Now I'm switching to my Cognos here. Let me go to my open menu. This time I'm launching a new item, present. Dashboard, report and story are available under the present section. So please click dashboard. This will redirect me to the dashboard page. All participants are requested to go hands-on alongside. Click the open menu. How we are creating? Click open menu, click new command. Under new, choose dashboard. Alternatively, you can go to the content, my content folder. Another way I'm showing here. Make sure you are in the my content section. For whichever data, raw data you want to create dashboard, you can click on the action menu and simply say dashboard. You can simply say the dashboard. I repeat, go to the content menu, right click and say create dashboard. This will also redirect you to the dashboard page, but that's not a recommended practice because we have to build our dashboard from data module only, our report and story in data module. So currently I'm in my dashboard page, create dashboard. Now in the create dashboard, as you can see, Cognos offers several design layouts to be chosen. If you want to create a plain dashboard, you can choose the default one. You can see section wise design layouts. If you have more visuals that you want to connect in the layout for a better rich insights, you can choose from the available design layouts. You can choose any of them anonymously. Selection is up to the need of the user. How many visuals you want to deposit, that many. But at the end of session, I will give some important points. How many visuals, how much data volume, how many data points you can display in dashboard. I will comment it at the end. Imagine I choose some typical dashboard, something like this one here. It's up to you. You can select and then click on the create button on the top. You can notice here, select the design layout. Two types of design layouts are available. One is tabbed, one is infographic. Infographic dashboards are also available. As a beginner, you can start with the tabbed variety dashboard. Select your required design layout and then click on the create button at the top. I'll just show one dashboard, quick one from the scratch. Then I also show how to pull visualization from my pins. Now I'm in my dashboard page. Participants, please check and confirm. Those are doing hands-on. You're also in the dashboard. Yeah, similar page. Thank you. Then the first step is you need to connect a data source to build your dashboard. So click on select source plus button here, or alternatively you have at the top the plus button here, add a source. Both will work for us. Either the plus button on top, that is add data source, or the select source button. Either way will be same, right? So I'll just go with the select data source button here, which is the data that we are connecting. The data is available in my content section named bike buyer 1.csv. Click add. Now the data are available. You can see that all the fields in the data are available. First visualization, I would like to simply build some raw visualizations. You can include univariate visuals, bivariate visuals, summary metrics. All this can be included in dashboard and formatted also. So first one, as per our research discussions yesterday, we could create some visualizations. Gender versus bike buyer, children versus bike buyer, so on and so forth. So what I do is I need to first pick up my visualization. Where are the visualizations available for the dashboard? On the left side of the pane, you can see some push button available for you called visualizations, which I've highlighted. This is the pins button. This is the data source button. This is visual. The remaining two are called widget sections. Widgets are value added in multimedia objects that you can add to a dashboard to make it look enriched. So first we have to click on the visualization section. Let us go with visual. I am just clicking on this visualizations. You can see here, I'm hovering the mouse. Click it. Cognos offers you a bunch of visualizations. The same visualizations which are available during EDA are available here in the dashboard section also. So two types, system and custom. We can go with system defined, system available visualizations. Let me select some graph here. Which graph do you recommend for me participants to study the relationship between gender and bike buyer? Recall your yesterday session's experiences, everybody. Gender is categorical variable. Bike buyer is also categorical. Correct. We can start with a column graph. but each of these two have multiple classes. Bike buyer has two class labels, yes and no. So we need to go for a better advanced one, that is a stacked one, either stacked bar or stacked column. Correct. So we can go with some better one, column or this one. I just go with stacked column. Drag and drop the visualization on the dashboard, participants. Simply drag and drop the visual. Yes, drag and drop. Same thing like what we did yesterday in EDA. We are building from the scratch dashboard initially with raw data. Please remember. Now, what should go into the bars section? Because our study is between gender and bike buyer. Bike buyer bars. Which one do you want to project? Bike buyer, I would like to show in bars category. As per your need, you can customize it. Then gender, I will take into the length object here, for instance. This is the length object. Then change the aggregation by choosing summarize count. Now this is the distribution here. For a better view, I again put the gender or bike buyer in my category. Select it and put it in color. I could get some basic visualization here, but is it meeting our requirement? Check out. Yes, no category distribution is there, but we need a stacked one, right? So this is not a perfect stacked one. So we can revamp it. I'll put gender in bars. You can revisit that again. Gender will go into bars. And the bike buyer will go into the length. You can rebuild it. Then take a count of bike buyer, that is yes and no count. And then show the bike buyer in the category. User can customize the visualizations as per the need. We get a stacked bar here, participants. You could see that clearly now, right? We build it, you can enlarge. The auto fit adjustment is possible, or you can manually change the size. Now we got a stacked bar which shows the distribution of bike buyers by male and female. The light blue ones are yes case and the dark blue ones are no cases here. Please produce a similar visualization, participants, everybody. Build your first dashboard with Cognos. This is the first visualization. That is this thing. You can rephrase your title. You are getting a default title, right? And when you go to the properties section, see properties, always make sure you apply properties for better understanding. Then if you want, you can place your legends wherever you want. Then values also, legend labels, chart. Under chart section, you can use values how you want to display as stacked percentage chart also you can consider. Or if you put it off, show value labels. Where are these options available? Please click on the current visual, go to properties tab, scroll down. Under chart section, you can play with the chart, show value labels, and you can mention the value format as percentage color. We all did this yesterday. Same operations we are repeating on the dashboard. Distribution of bike buyers by gender. So you can rename your title here. This is bike buyer by gender. I'll just delete this extra text I produced. Sorry, I delete this extra text here. So how to handle that? The color and theme can also be applied. There are many parameters. If you scroll up and down in the properties section, you can just simply you can configure that. I'm deleting this extra text and I'll rename my graph as bike buyer by gender. Could you all get this graph created, participants? Please check and confirm. The field positions go like this. If you click on a graph, currently the field positioning is, we have gender in bars, bike buyer in length, and bike buyer in color. This is one stacked column that we produce between bike buyer and gender. Similarly, if you recall, yesterday we connected our visualizations to pins. Do you all remember that? After creating EDA, I advise you to connect all to the pins. These are pins. Yeah. Turn down label bit, it is not showing on graph. Make sure the option under properties, the dynamic label is there. Under charts, if you see, handling, the labels and everything are available. And the beauty of Cognos is under the chart section, participants, please notice very important item. refresh automatically is available for a time frame. What is this refresh automatically here? Where is it available? Under properties tab, under chart section, refresh automatically is available. If you turn this slider on, if you put on this slider here, Cognos will ask you, should I refresh the dashboard automatically as and when the backend data gets updated? As and when the backend data is uploaded newly, streamingly, do you think this dashboard should also refresh automatically by themselves, participants? What do you say? If that is your choice, you can turn on and set the timer. Within how many seconds and minutes the dashboard should automatically refresh. Those are called dynamic dashboards actually. When a new copy of data is uploaded, currently Bike Buyer is having 7,000 rows of data. Imagine if I upload 70,000 rows of new Bike Buyer data set, should the dashboards be refreshed automatically or not? Correct. That is true business intelligence. So you need not build a project. You need not build dashboards each and every time. Once you build one dashboard and set it to the refreshment requirement settings, as the backend data gets updated automatically, the dashboards also keep them refreshing as per the set features, provide true business intelligence in real-time streaming. This is how Cognos and other analytics tools would empower on-demand BI. On-demand is when the data are updated, the analytics also acts on it parallelly. That is one rich feature that we could use in this project of dashboards. Then let us build another dashboard, another visualization here for information. Right. So this is one thing. To build, you can keep adding your visuals, or the quick and best possible way is select from your pins. How to pull the visualizations from our pins? Click on the pins section here. Click on the pins. Now notice when I clicked on pins yesterday, some handy visualizations we created in EDA and we attached them to the pins. Could you all see on the left hand side where I'm scrolling, participants? Those who have added their visualizations to the pin section would by this time realize what is the benefit in pinning the visualizations of EDA. Directly you can drag and drop visualizations on your dashboard. One way is build from the scratch each visual, or other way is explore the data in EDA exploration page of Cognos, generate required visuals, connect to pins, pull those visuals from pins and present it on the dashboard. So I have gender, Bike Buyer by gender. Next one, I am trying to drag from my pins here. Are you able to see my pins clearly, participants? Please check out. Are the pins being displayed here on my screen? Left hand side, how did I get those pins? On the left hand side, the pins were there. Yesterday demonstrated how to connect to pins. I'll drag each visualization and deposit on my dashboard. Then I'll resize it. I'll just put this off. Yes. Using the placeholder. Look at this placeholder here. If you want to move your visual on the dashboard, you can use this 4-dimensional placeholder and then start moving your dashboard in any way that you want. You can place the visual elements on the dashboard. So I just move it aside by resizing. Better to resize to accommodate more graphs here. I can just resize them here, right? I would also resize this by dragging the corners. Alternatively, you can set the width and height of the visual. When you go to properties section, first you have to select one visual and you can set some general properties here in general tab. In general, can you see the width and height of the visual here? You can set it the predefined limits of width and height of each visual. A good practice is to follow certain standard width and height for all visuals commonly for better presentation. Now this is one thing that we have here. You can enlarge it. As you see, if you want to add some visual rich insights, you can go to the properties under visualization section, go to the chart section, make sure you have the value and percentage enabled for this current graph. You can set your properties. Yes, now properties I have switched on. You can see the data labels and percentages on the stacked column and stacked bar. So there is a lot of customization that can be done here. Similarly, I want to add more. I would like to add how Bike Buyer is distributed by car count. So build this. Add the bike buyer by age group. Yesterday, recall we have built age groups, right? Data groups we have created participants for information. That visual is already available in the pins section. So pull each and every relevant visualization, but make sure what are the most critical insights that only has to be included, as I stressed a few minutes ago. Then what else can we use? Do you think bike buyer is affected by the number of cars of the respondent? Yesterday, we debated a lot on this, right? So even drag the cars visualization also. Bike buyer by cars. So drag and deposit in the dashboard. You can position all the visualizations in a very structured manner. You can just make sure the dashboard is looking pretty beautiful. Now I have 4 visuals on my screen. One is bike buyer by gender. Okay, bike buyer by cars already I have, so it is duplicated. I'll remove it here. The next, any other important things do I have? Yes, yearly income distribution graph is there for us. Box plot is there. I'll pull the box plot here essentially. I'll resize it. You can place them in any order. Any graph can be on the any order. Currently, all visualizations, if you carefully notice, are being present in tab 1. You can add multiple tabs by clicking on the plus button. You can add tab 2. Tab is means one section. If you want to add more visuals, you can add multiple tabs and collectively call it as a dashboard. But there are some tips on the upper limit of the number of data points on the visualization, which has to be understood. Because too many visualizations, do you think will clutter our dashboard or not? What do you say, participants? If you unwantedly put insignificant visualization, that will clutter, disturb our dashboard. So avoid doing that. Put key insight visualizations only. Correct. So make sure we have certain this thing, outlier presence. Any others also? And one more thing, apart from the visualizations also, we can also use some other value added things. That is, we can add some tables here. So I go to my visualization. Currently I have 4 visuals, as you can see. If you want, you can go to visualization section. Right, there is one facility called cross tab. Could you see that here? Under system, I have a cross tab. What is this? Rather than projecting the data in a visual format, you can tabulate the data also. For example, as a data analyst, you are interested to know how many male and female customers with what occupation are they saying yes or no. So in cross tab, I would like to project by gender, by occupation, how many respondents have favorably and unfavorably responded. So how many variables are we presenting in this cross tab? One is by gender, one is by occupation, and one is by the target variable. We are doing a multi-dimensional presentation here, multi-dimensional cross tab. So select cross tab. Full form is cross tabulation, which is a statistical instrument mostly used for presenting the data in tabular format. Drag the cross tab and deposit in your dashboard. I repeat, where is it available, participants? It is available in visualization section. Under system category, select cross tab instrument to be included in dashboard and drag and drop it. Now we have this cross tab. Go to data sources. In the cross tab, I would like to show what has to be going to columns, what has to go into rows, and what are the values to be computed, aggregated. My question is, I would like to show how many male and how many female respondents are working in different occupations and whether they have said yes or no. That is, bike buyer is my target variable. So I'll drag my bike buyer into the column shelf. And in the rows, I will take occupation. I'll take occupation. And under values section, or I'll put bike buyer in values here. And gender, I will take into my columns. See how we are building the cross tab, participants. Gender into the columns and bike buyer count. So for the values, I will choose the aggregation as count. Different occupations, or typically you whatever you need, you can customize that. according to your requirement. So the first one is we will drag the cross tab into our dashboard and then choose the values accordingly. Either you can choose the bike buyer into columns or gender according to your need. Occupation will go into the row section here. Then we will choose the values, that is the bike buyer, or gender we will choose here into the values. So we have here no and S categories and quite small. If you would like to do a binary analysis, you can exclude gender for time being and still take bike buyer only as your values. To get more rich insights by occupation and bike buyer nature, now the values go higher. You see the count is now running, count distinct is running, correct, count is running. So please build this cross tab, participants, everybody. Bike buyer over occupation. Rather than presenting it as a visual, you could clearly see, I could create the cross tab here, right? So dashboard need not include visuals only, but other elements. But mostly from the definition of dashboard, it is expected to contain visualizations only. If you want to include cross tab like objects, you can include them in reports, which we'll be dealing on the last day. Report is a collection of visuals and other information elements. But mostly in a dashboard, make sure the default is include all visualizations only. That is the trademark of dashboard. Now we have some elements connected here. I have bike buyer by gender. I have bike buyer by cars. I have bike buyer by cars here. Let me position it here. Yes. Let me read this title. And I have bike buyer by operation. You could see here, bike buyer. You can revamp the title. Yes. You can format this also, add some formatting features. Bike buyer by occupation. And this is bike buyer by age group, participants. You can see, you can refresh. Bike buyer by age group. And this is yearly income and bike buyer distribution. Yearly income for bike buyer. Make sure you handle them correctly, because many elements would bring certain challenges here, right? Now we have built our dashboard. I hope all of you could do a similar one. Please confirm, participants. You can add any visuals of your choice. As per your insights, you can identify the KPIs and build them. Correct. Now there is one button on top for presenting this. This is a full screen dashboard button, which I highlighted in the toolbar. Could you see that? That is called switch to full screen button, so that you can see the dashboard very effectively. So please click on that full screen. Now we are presenting the dashboard on a full screen. Switch off this data source here. Yes, click the button. Make sure all the visuals are. Can you see the dashboard on full screen, participants? The view which I was using previously was design view of the dashboard. This is called presentation view. The beauty of such a dashboard, if you could see here. Am I audible to all of you clearly? Please confirm. Can you hear me? Yes. If any visualization you want to remove OFG, just click on that visualization, highlight it. Just click on the visualization and press delete key from keyboard. Whichever visualization you want to delete, participants, just highlight with your mouse click and press delete key, that is gone. So that's why you have to be very careful while presenting the dashboard. Now the beauty of this dashboard is, this dashboard presents insights of the business: bike buyer by gender, bike buyer by cars, distribution of bike buyer by occupation by table, bike buyer by age group, and yearly income from bike buyer. In this dashboard, the interaction now will start. This is called dynamic and interactive dashboard. Now imagine if you want to see how many female respondents positively, favorably responded. I repeat the first question, the first pattern. we are now finding from the dashboard how many female customers actually responded yes. In the first graph, which is called bike buyer by gender, which color, as on my screen, you can see the light blue color is yes category, the dark blue color is no category. So first I'm interested in studying female customer characteristics. So I just click on, I just go with the female and click on the light blue color. Accordingly, you people operate and see how other graphs are visually filtered automatically. The patterns get filtered, notice. Now I just click on the female. Now could you see the dashboard is being filtered automatically or not? Check out everybody, give a try. Experiment your first BI dashboard with raw data. Just click on the female category, yes category, because no category we are not interested. No is already, they said no. Let's say, let us understand what makes a female respondent say yes. 52.2% of the female respondents said yes, they want to buy bike. Then if you see bike buyer by car, I'll just reposition this graph here. Yes, so that you can see which type of customers actually being female, what is the distribution of cars they have. Now look at the second graph, participants. Those females who have either 0 cars or 1 car or 2 cars, they are the ones who said more yes. Come on, drill down the data. Once I clicked on the female category, go to the second graph. Second graph is bike buyer by car. What are the characteristics of the female customers by cars? Those female respondents who either have 0 car or 1 car or 2 cars, their bars are longer here, indicating they are more interested to buy bike. But what about the females having either 3 cars or 4 cars, participants? Check out. Now the dashboard is brought back again, and again I'm filtering it. Visual filters I'm applying. What about the females who are having 3 or 4 cars? Are they more likely to buy or less likely to buy? Come on, the dashboard is now interacting with the insights. Patterns are presented with each click. The chance of female customers, female respondents who either have 3 or 4 cars are least probable. You're right, Ranuji, you're right. Then if you see the bike buyer by occupation, again, the beauty of this table, which type of occupation female respondents are more likely to buy? Look at the cross tab and present the insights for me. Look at the bike buyer by occupation. Categories are clerical, management, manual, professional, skilled manual. Females of which occupation category more showed enthusiasm in buying the bike? Very good answer, Jayabji. Professional, because the yes category we are dealing, how many females are working as professional? Take the count. 164 females belonging to the professional category said yes. Now, do you think by exploring the data through visuals, connecting the visuals on dashboard is a great opportunity for the organizations to discover the real insights or not? What do you say, participants, everybody? Correct. This is called business intelligence with data analytics. All organizations should follow this data-driven BI analytics so that they can discover the real facts. Correct. Now, which age group of the females more said yes? Come to the bike buyer by age graph below. Bike buyer by age group, if you see, which age group of the females more likely favorably responded? Females who are in the age group of 30 to 40 years showed more enthusiasm in buying the bike, yes, followed by 40 to 50. Like that, find out which age group has less interest in the bike buying group from the graph, least or more unfavorableness from the age group graph. Respondent be a female and age group, least one. Shortest bar you have to find out for me in the age group graph. People who are in the age group of 70 to 80, Ranuji, very good answer, nice. Other participants also, please try to understand the BI dashboard and write your answers in the chat. Female respondents who are in the age group of 70 to 80 years, the number of positive responses is very less. Look at the length of the bar, very less. You're right, Sharadji. And if you see the income distribution of the females, Are there any outliers in female respondents' yearly income? Participants, check out. Do you find any outliers? Yes, in the box plot on the female category, there are some handy outliers. There are some female respondents whose yearly income is quite higher. But the distribution says what in the box plot? The yearly incomes of the female respondents who said yes. I repeat, understand the interpretation. The yearly income of the female respondents who said yes are distributed in which range? Anybody look at the box plot? Look at the box plot carefully on the y-axis. The incomes ranging from 1 lakh to 2 lakh yearly income are the ones who are more likely saying yes. Look at the y-axis of the yearly income box plot, everybody. The people whose income ranges are lying between 1 to 2 lakh, correct? They are more likely to say yes. Now, do you think these many insights are very useful to the organization before they actually manufacture and advertise and sell the bikes? That's why a need analysis, market research, data collection, data exploration, data pre-processing, and dashboard management are all generating business intelligence for the organization so that they can plan the production engineering process accordingly. Today, the bike buyer company, before starting this FDP, is a production engineering company. But after doing the 5-day FDP, is now the bike buyer company a smart data-driven decision company? Do you agree? What do you say, faculty? After this 5-day journey, definitely understanding the essence of business intelligence and data analytics, they are the smart manufacturing companies, I say. Thus, each one of us, if you excel in the data analytics research with these tools or other technology and more research instinct, data instinct, you have the parallel opportunities to serve as consultant advisors for industry also. If you gain the rich experience and exposure through such FDPs organized by SmartBridge, you can gain the rich industrial consulting experiences to add value to the business processes, besides your regular duties as academician. Make sure such kind of knowledge culture is reflected post FDP at your organization, participants. Include that in your curriculum to empower the students also. Yeah, yes, there must be some commonness. You're right. Our KPI is common. Yes. Need not be variable common, Jobji, but the KPI should be common. Our objective of building visuals in dashboard is to get rich insights actually. Then no, there is no way. You can start with gender. Alternate, you can start with marital status also. You can start with occupation. But make sure once you make one graph as a basis, the rest of the graphs are filtered. That is, one graph can be called a source, rest all are dependent graphs, Zoebji. You can start that with any graph. Not only gender graph can be source and others are dependent. You can make cars graph also as a source, occupation graph also as a source, rest can be dependent. Interdependent filtering can be done. Now I am switching to the male category. Look at the males. Now I am filtering the dashboard by male category. All the graphs automatically adjust themselves. What are the patterns interesting in the male category, everybody? Please check out. Tomorrow also we will deal with the dashboard session, tips and tricks. I'll be discussing tomorrow, and we will perform a real-time case study with banking research analytics. That value-added dashboard we will create in tomorrow's session. Of male customers, what are your findings, participants? Please quickly write your interpretations in the chat. Correct. Age group 30 to 40 years of males more favorably responded by saying yes. That is one insight. Other participants also, please share your interpretations of this male customer behavior in the dashboard. Like as females, number of cars with 0, 1, and 2. You're right, Sharaji. 30 to 40 age group is quite great. More or less reflecting as female. That is, in terms of cars, those male respondents who have either 0 cars or 1 car or 2 car, they are most favorably responding. What about the occupation participants? Like as male, like as female, more professionals said yes towards buying cars. More professionals, 142 professionals. Very good answer, Sharad Gupta ji. 142 professionals would have favorably responded yes, followed by skilled manual. And such 142 professionals who have 0 cars combine the insights. You need to present interpretations by combining. So in a simple outset, how we have to define? Being 142 professionals having 0 cars in the age group of 30 to 40 year in the income distribution of 1 lakh to 2 lakh are more likely to say yes. So when we want to present the insights to the top level management, you need to take all the visual insights and combine and present it. That's where. Alternatively, if you click on the analytics tab on top of it, you can see the analytics option available. The narrative insights could be projected. We can add the narrative insights from this if available, each one, and drill down the narrative. So the tool is finding the narrative insights for you to help you. Great. If you cannot discover the insights by yourself, participants need not worry. Cognos assists you, helps you. When you click on the analytics section, all the insights are generated in the dashboard, which you can use in your research report greatly. How did I do that? First, create my dashboard and then drill down the data by myself. If not, I'll simply click on analytics insight. To bring back the dashboard to original state, because now it is currently filtered, you can see a filter icon applied. All of you can see. When I choose a particular item, the funnel icon appears showing filter. When I click outside of the graph, the funnel icon disappeared. Would you notice that? When you click or a hover and you click any item, the funnel means filter icon applied automatically. If you want to remove the filter, just click outside of the graph anywhere in the dashboard. The original graph is recovered. And in analytics section, you see Cognos giving you narrative insights for that. Is it clear? Right. Hope all of you understood the appealing power of dashboard, how to return back to the design view, how to switch to design view. Simple. You can now push this button from full view or full screen view to design view. If you click on this button again, you will return back to the design view of the dashboard. So simply go here and put exit full screen button. Now I am in the design view, participants. Could you see that? We have recovered back to our design view. You could now understand the data sources, the pin button and visualization. Then what are these widgets in the dashboard here? Let me finally add value before we go for Q&A. What are these widgets? Widgets add more cosmetic look to the dashboard, participants. Please take a note of it. To add more cosmetic look, we can add some multimedia objects from our widgets section. So let's explore widgets here in quick time. I'll go for the last one, widgets. There are custom widgets and widgets here. First, let's go to the widgets. Click on the widgets, which are available in the design view. And you can see many more graphical widgets are available. So to add more value, what I do is I'll select a female icon here, woman icon. I'll drag and drop the woman icon on the female section here. So these are all value-added cosmetics. They are not compulsory, but to make your dashboard more interpretable. This is a female icon I have added here. Then I'll pick the male icon in widgets, man icon, and simply I can just drag and drop it here on the man icon here. So this is called real-time cosmetic look to the dashboard. You can add the man icon here at the center. Similarly, if you want to add some meaningful look to the car's dashboard, you can pick up a car which is available here, the widgets, drag and drop the car. You can format the objects also, add colors and other things, and drop it here, resize it. All these widgets are available for sketching out, painting your imaginations correctly. Then wherever required, you can add the required one. If you want income, this is sign is there. Wherever required, you can bring the dollar sign and drop it here. You can resize it. For income, I am putting the dollar widget here to add more. Not a mandate one, but that add more value. For a better grasp, you can format your objects. Click on the woman icon we added, go to the properties section. And you can just choose the appearance here. You can choose the color of your choice. I can choose an yellow color here for better eye-catching visualizations. Click on the widget that you have added, go to the properties tab and go to the appearance and choose some fill color of your choice. You can choose any lighter ones that reflect the differences. Yes, correct. Then similarly for car widget that I have added here, I can just choose the appearance and select some car here. Right. Like that, you can add some value here. Now you can present your dashboard. Look at great, looks great. Yes. Widgets add some extra value representing some cosmetic object look to your dashboard. Right. So at the outset, this is how you can quickly do. But is it a true BI dashboard or it was built on raw data participants? What do you say? Is it built on the raw data or is it a pre-processed? Completely, it's a raw data dashboard, right? But make sure you take the raw data to data module, clean the raw data thoroughly after explorations, save the data module first, and then build your BI dashboard on top of data module. Finally, add widgets for better interpretation and cosmetic look. And finally, the last step in today's session is we can share this dashboard to our colleagues also, co-workers. I repeat, after creating your dashboard and designing it, you can click on the share button, which I just highlighted here. Just click on the share button. Cognos provides the facility to share your work to your project co-workers, collaborators. Three options are available. One is send here. You could see that. Either you can send the dashboard by as an email attachment. You can click email and click next and add the recipient's email ID next. Or you can directly share the dashboard as a clickable link. But before that, first you have to save your dashboard. Just click on the save icon, provide some meaningful name, bike buyer BI dashboard, I say, or raw dashboard, anything. I'll save my dashboard asset in my content. Without saving, you cannot share. Please remember that the prerequisite, you have to save your BI dashboard as an asset. Now you click on share button, participants, send it as an email or generate a clickable link here. You can see when I click on link, you can generate this link. You can copy and share it to your users on WhatsApp, Facebook, LinkedIn, or any other messaging platform. Directly clicking on that link will open your dashboard page on their device. Then alternatively, if you want to export the dashboard, right? Cognos also provides you the facility to download your dashboard for your future experiments. The default format available is PDF only. So export to PDF and simply you can say export here, the export button. Now you can see in the backend building PDF is being done. You can print to different formats from here. Save as PDF. See more are there. Other formats you can save, whichever is required. The default is print to PDF and click print. Now your dashboard gets printed wherever you want. You can save your dashboard, participants. That's it. On desktop, I have downloaded my dashboard as a PDF, right? Where you can email. So dynamic interactive dashboards, sharing them as an external email attachment or a shareable link or a downloadable export are all also the additional features available for us in Cognos Analytics platform. Hope everybody could understand the initial introduction to what is dashboard, why we need to prepare a dashboard, how to create dashboard from the scratch and connect pins available on EDA and then drill down the patterns from the dashboard or add value added analytics insights, add some widgets for better cosmetic look, and then finally share our dashboard to the project teams across the organization is demonstrated today on the day 5 evening session for you all. So that's it from my side. Shivam, you can open the floor for question and answer for this session.
Yeah, thank you very much, sir, for delivering such a good session. And dear attendees, I also want to express my gratitude for your participations in today's session. So today we covered various essentials topic, including different visualization techniques and dashboard creation, and also understand about how to share it colleagues and all.
Yeah.
So I encourage all of you to take this opportunity to ask any question, or if you seek clarification on the topics which we discussed today. So now floor is yours. So I request to all the participants, if you have any queries, you can ask your questions. I'm now open. Now I'm giving the access to all the faculties to unmute themselves and ask your queries, or you can post your queries into the chat box itself.
Ranuji says, can we receive, can receiver get pics? Ranuji, for information, entire dashboard will be shared to the receiver, madam. It's not just one image. whatever visuals you have included on your dashboard, entire dashboard will be emailed or linked on a shareable link or downloaded on the dashboard. For instance, I have downloaded my PDF. Let me show that for the confirmation. See, I have downloaded my PDF here. I open the PDF. Make sure we have a PDF reader software. Now, if you could see here, when I just downloaded, could you see only one or two visuals, Ranuji, or is it the entire dashboard that was downloaded for confirmation? Please check that.
The entire one is there.
Correct. Same way, the receiver will receive the entire dashboard, whatever visual elements are there at the time of sharing.
So can receiver find out the selection procedure that what we did, like female considers, then the automatic visualization?
See, that's what, if you save it as PDF, it is a static one. But when you share the link, I mean, as a shareable link, the advantage is the receiver can also work with a dynamic dashboard. The receiver, he or she, can interact with the dashboard by filtering the inputs also.
So without logging into IBM Cognos.
Yeah, that's why the compatibility is a great benefit here. See, for example, if you are creating a PowerPoint presentation on your side and you're giving it to me where animations are there. If I download the application PPT, naturally some application software is required or not. But
yes, sir.
The greatness of analytics tools is the environment need not be a mandate for operation in the backend.
Okay.
The environment need not. It is, that's why real-time collaboration. But how does it work is your device tries to connect to the web, provided if you have internet that is sufficient.
Okay.
That's the beauty of these tools.
That will be very good one.
Yes. It's a real-time interaction. Otherwise, dependency on the application software again demands the end user to have the software for interaction.
Yes, sir. That limits our work also.
Exactly. So if you want to share your great research thoughts with your global world, and if they don't have software, the application doesn't pop up, right? For example, to open a PDF file, we need Adobe Reader, right?
Right.
That's a cloud. Web-based BI, cloud-based computing is always a benefit, remember.
Thank you. Thank you very much, sir.
Yes. Any other questions, participants? Please let us know.
Sir, this is Zohaib Hassan.
Yeah, Zohaibji.
Sir, the iframe links that you showed, the middle one, the option.
Yeah.
So if I put it like a tag in my HTML page in web application, will it dynamically change as from the back end somebody changes?
See, integration is a different issue, Zohaibji. Again, your idea is good. If you connect the current dashboard with a shareable link and try to reformat in HTML, again, certain kind of integration architectures need to be connected between the backend Cognos environment and front-end HTML. Because if your internal essence is to design a website with the insights, right? I repeat, as a data analyst, as advanced data analyst, if you want to show all the drill down insights you generated in Cognos and want to present in a dynamic website is a very good idea. But backend plugins have to be done. Fortunately, cloud-based tools have REST API architecture, Zohaibji. Yes. REST API means representational state transfer. That's why with some minor integration connectivity, still your Cognos environment dashboards can be presented directly as a separate website also. Thus, REST API integrations is again a value-added discussion, which is not included in this syllabus, but you can explore. I could advise you to go with REST API integration of HTML with Cognos. That can be done possibly. Yes. Any other questions, participants? Let us know. Usually that would come in the production product release environment. If you want to develop your own website as a product, as a BI website, and want to share it to the real world in production release environment, that architecture knowledge is very important. Yeah. Let us know, participants, if any further questions are there from you.
So like an IoT monitoring tool, right? Like
mostly, yeah, sensing system. If you want to say sensors pump the data, connect it to Cognos, analysis done on Cognos side, presentation done on web-based, another web-based third party. We call it as the pipeline, the data analytics pipeline. From data collection to endpoint projection and deployment, deployment on the endpoint. But for that, a robust environment, unlike Cognos, which is basically analytics environment, If you want to achieve such kind of a data science product, we would recommend you to go with IBM Cloud Watson Analytics environment, where you can do data exploration, visualization, predictive modeling with machine learning algorithms, then develop, evaluate your product and deploy in the endpoint also. For that, IBM Cloud Watson machine learning is most suitable.
It can be real time as well.
Complete real-time project, yes. End-to-end project deployments completely. Correct. Any other questions? Let us know.
Yeah, dear participants, if you have any other question, we are open for Q&A. So I request you can post your queries or you can unmute yourself. Or if you do not have any query, then
yeah,
we can sign off for today.
That's all for today from my side. And thank you all for your great patience listening to me from all viewers. And over to you, Shivam.
Yeah. So yeah, thank you for being a part of this wonderful session, dear participants. And we will look forward to assisting you further for upcoming sessions. So thank you very much. And today we are going to be signing off. Thank you.
Signing off.
Thanks to all. Thank you, sir. Thank you. Thanks to all the participants.
Yeah.